Hello everyone. For this practice exercise, we are to determine the standard form of a quadratic function given the following details. For number 1, we are given with the intercepts, as well as for number 2. Number 3, we have table of values, while in number 4, we have a sample graph. We are to work on these items one by one. Let's start with the first item. If you are given with intercepts, just like this in number 1, you need to understand that these 2 points here represent the intersection of the parabolic graph and the x-axis. By saying that these two are the intersections on the x-axis, these are specifically termed as x-intercepts. And the values for the x-coordinate represents the value on the x-axis where the graph intersects. Now, further, we can discuss this as these two values given by the x-coordinate are actually your roots of an equivalent quadratic equation to your function that is actually making the entire value of the quadratic form be equal to 0. Again, these are roots of your quadratic equation, which is also important to understand as we are going to work on these concepts in getting the standard form of quadratic function. In order for us to go further, we need to understand the process of solving roots because we have, again, understand that these are just roots of an equivalent quadratic equation. When we have this form, x minus r times x minus s be equal to 0, we have two factors and their product is 0. By the zero factor property, it tells us that we can just separate them into two different equations where we equate both of the factors to 0. So we have x minus r equals 0 and x minus s equals 0. And by the use of the properties of equality, or the shortcut we also coined as transposition method, we could get the two roots here, the first being r and the second being s. These again are the processes of solving roots by factoring, where we include the concept of zero factor property. We are going to use this to determine the equivalent standard form of the quadratic function by working on this backwards. Let's say negative 3 and 11 are the values of r and s. And just for the purpose of this illustration, let me remove the subs here, the subscripts for the values of the variable x so that we could connect them to this concept. This means that by working backwards, whatever value of x that we have, we just need to return it on the left-hand side of the equation so that we could have an equation equal to 0. I'm talking about moving these two values to the other side using transposition method, or simply using the properties of equality. For the first, you add 3 both sides. For the second, you subtract 11 both sides. I'm talking about this step. X, when I move negative 3 here, it will become positive 3, be equal to 0. As for the second, you will have x, and as I move 11 to the left-hand side, the positive 11 becomes negative 11, equal to 0. Now, these are the two forms from this step here to here, just by working backwards. Now, if we move a little bit closer to the original form, these two were just separated by the zero factor property, and hence, this tells us that if we are to multiply the two binomials formed x plus 3 and x minus 11, this will result to 0. Again, this is the reverse operation of the zero factor property that from factors you get the roots, and here we have the roots as the intercepts, and we return the operation to get these two binomials here. The result of multiplying these two binomial will be the representative for your function of x that would be fitting to have the intercepts negative 3, 0 and 11, 0. By the way, before we continue, I need to emphasize that whatever function that we may get is only one of the possible functions that you could get with these intercepts. Here, it doesn't even say that the function is either opening upwards or downwards, or other details may be given. In short, what we can get here as a function is just still correct, but it may just be one of the possible functions that you could get using these vertices. Now, let's combine or multiply these two binomials using the FOIL method to get the value or the quadratic form that could be substituted, placed here rather, to be called as the standard form of quadratic function that will represent or may represent or one of the representatives of having these two intercepts. So we are using the FOIL method, we'll have x squared, x times negative 11, negative 11x, 3 times x is plus 3x, and then you will have here 3 times negative 11 minus 33 equal to 0. And you will get the form x squared, that's minus 8x, and minus 33 equal to 0. Now this is now the representative or the equation form following the reverse operation of the zero factor property, but we are not going to take all of this to be our function. We are just going to take this portion here without equal to 0 since equality is already here and place our results this to this one. In short, the sample or a representative function with x-intercepts negative 3, 0, and 11, 0, or specifically a representative quadratic function in standard form is given as x squared minus 8x minus 33. This is the correct or one of the correct standard form of a quadratic function that represents these intercepts. So again, if you are given with intercepts, you can determine a sample standard form of quadratic function or one of the possible forms that will represent such intercepts. Let's proceed to number 2. Here in number 2, these are still intercepts. You would know that by looking at the given points. If the y-coordinates for the given points, such as this, our y-coordinates are both 0, then the equivalent x-coordinate are considered to be the value in the x-axis where the graph intersects, or again, the term that we use are intercepts. We connect this to the concept of roots since these x-coordinates represents our two roots. Or we could write it this way, x equals 0, and the second one without the subscript equal to 4. So same thing here. Earlier, we are going to use the reverse operation of the zero factor property to get the binomial if we have 2 or number 1. I don't know if we still have 2 for number 2, but let's see. And whatever will be the result will be our given quadratic expression for our function. Here, since the first value of x is already 0, and no matter how you move this to the other side, it will still be 0, so this is already your first form. The second form is actually x, and when 4 is transferred to the left-hand side, we'll have minus 4 equal to 0. So you have these two forms now, and only one of which is a binomial, as compared to number 1, where both has constants other than 0, hence you have two binomial expressions. So here, we're only given with this. You have x times x minus 4 equal to 0. And then we are to get the product of this and place the result here to get one of the possible standard form of quadratic function that could end up with these two intercepts here. Earlier, we used the FOIL method since we have two binomial expression. Here, we only have one binomial expression. Hence, what we could use here is a simple distributive property. In short, our given function here is the product of x and x, which is x squared minus 4 times x, which is 4x. This is now the final standard form rather, of a quadratic function using these intercepts. So notice the difference of this with the first given. We used again the reverse operation of the zero factor property. Moving forward, for number 3, we are not given with intercepts. We are given with a table of values, but in this table of values, we can still draw intercepts. Before we proceed to that, let me move this graph a little bit farther, probably here. And what are those intercepts? As mentioned earlier, the intercepts are the points that is the common intersection point of the graph and the x-axis. That's for the concept, but for just by the given, look into the values of f of x or y, and if those values are having 0, that means the coordinate that represents that are what we call as your intercepts. So our intercepts here are given to be 1, 0, and 5, 0. So same thing as number 1 and number 2. This is our first root, and this will be our second root. So our first root without the subscript, x equals 1, and the second is x equals 5. Then we do the same process as done earlier. So our two roots now, rather, are binomial expressions. Since both of them are constant, the first one is x, the positive 1 becomes negative 1, equals 0. The 5 here will also be moved to the other side. X minus 5 equals 0. And the two binomials are x minus 1 and x minus 5 equal to 0. We have two binomials, so we use the FOIL method here, FOIL method, and whatever the result will be, that's your representative standard form of a quadratic function. Let's do it. X times x, you'll have x squared. X times negative 5, you'll have negative 5x. Negative 1 times x is minus 1x, or simply minus x will do. And negative 1 times negative 5 is positive 5 equal to 0. Our standard form of a quadratic equation is x squared minus 6x plus 5 equal to 0. Again, we will not be we will not be taking the entire expression here, just this quadratic form, and place it here. Therefore, our function is given as x squared minus 6x plus 5. This is now our given standard form. So if your graph, or rather, in your table of values, if your intercepts are given, you may use it to get the representative of your the value of your function. Or if your intercepts are not given, then you need to use the vertex. Before we go to that, let's have number 4 first. Since here, you also have your intercepts here, here, and here. So the first intercept is at 1, 2, 3, 4, 5. It's 5, 0. And the second intercept is 1, 2, 3, 4, 5. Let me check again. 1, 2, 3, 4, 5, 6, 7, 8, 9 rather. So we'll have 9 and 0. Luckily, your intercepts here or these points are really the intercepts. But if in case that we cannot solve them, we need to use the second form. We need to use the form where we use the vertex to get this standard form of quadratic function. But first, let's differentiate it by sticking to the first process that we know, using the intercepts. So our intercepts are 5, 0, and you have 9 and 0. Okay? So your first value of your root is 5, and the second is 9. So your first binomial is x minus 5 equals 0, and the second binomial is x minus 9 equals 0. And hence, you will have to multiply this x minus 5, and then you have x minus 9 equal to 0, which will again allow you to use the FOIL method. And the FOIL method here will be shown to this form. X times x is x squared. X times negative 9 is negative 9x. Negative 5 times x is negative 5x. Negative 5 times negative 9 is positive 45 equal to 0. In the standard form of quadratic equation, you will have x squared minus 14x, and then you will have here plus 45 equal to 0. Placing it in a function form, your standard form for this graph is x squared minus 14x plus 45, and this is your standard form. Again, we are lucky enough here to know our intercepts, and hence we just simply duplicated the processes that we have earlier. Just like this, and here, and here. Okay. The next video will talk about possible graph or table of values which will no longer have intercepts on it, or even if it has intercepts, it's not clearly stated as a whole number, and is therefore we need to use separate processes to get those. So we are just going to move to our second practice exercise to talk about that, because in the next practice exercise, we will be using the vertex instead of the intercepts. You may use this video as part of your review. Goodbye, everyone.